Hello and welcome back to Stats. I'm actually wrapped up class a couple hours ago, not even 2 hours ago, and I figured let me give you a quick video just to remind you of what we talked about or some of the things we talked about near the end of class and reintroduce the assignment that you have. So, first off, here's the list of numbers, exact same list of numbers. I didn't erase the board, so starts at 12, high numbers 41. We have a median of 30, or 6 out of 11 terms. So I talked about data presentation in 3 different ways. And these are actually 3 different ways of saying the exact same thing. So, first off, we have the frequency distribution table. Here we've grouped our data in classes, frequency classes. Frequency means how often or how many. So we have 2 in the 10s, so 10 to 19 we have 2. 2 in the 20s, 20, 29 we have 2. We have 4 in the 30s, and we have 3 in the 40s. Boom, and that's where they all come from. Now, the frequency distribution table corresponds to the histogram. The histogram is the visual depiction of a frequency distribution. That's all it is. Visual of the table. But at a glance, obviously, you can see a little bit more. You don't have to think as much. I color-coded it for excitement. But you'll notice the exact same things. 10 to 19, 10 to, I actually did 20, 30, and 40, simply because those are the breaks. That's where our classes change. So, you know, in the 10s, you can see we've got 2. In the 20s, you can see we have 2. In the 40s, or 30s, you can see we have 4. And in the 40s, you can see we have 3. Now, a histogram deals with ranges, 10 to 19, 20 to 29, so on and so forth. Because it deals with ranges, the bars necessarily touch each other, because when one range ends, the next one automatically begins. It's not a bar graph. A bar graph is where you have very specific values typically, and you're not dealing with ranges. There's no reason for the bars to touch. So in a bar graph, the bars don't normally touch. Although I've seen people, you know, kind of fudge it a little bit, but that's okay. But note the difference, one of the major differences between a histogram and a bar graph is in a histogram, the bars always touch, because when one range ends, the next range begins. So that is the visual depiction. We also talked about kind of the unreliability of the histogram and frequency distribution, because, you know, we don't know from looking at this where our median would lie, or let alone our mean. The halfway point, you know, you look at it and you say, yeah, it's probably around here, so maybe 33, 35, something like that. Well, in this set of data, it's actually 30. It could have just as easily been 39. We could have had 4 39s here. So you can see we don't learn a lot. We get a ballpark estimate, but we don't really learn any specifics from the histogram, other than the general shape of the data. Stem and leaf plot, however, accomplishes the same things that a frequency distribution and histogram accomplish, but it gives us specifics. So you notice our stems are the 10s, and our leaves are the 1s places. So we're just taking each number and breaking it down. So 12, there's your 12. Stem 1, leaf 2. 13, stem 1, leaf 3. 21, stem 2, leaf 1, and so on and so forth. And if you turn the stem and leaf plot, or rotate it 90 degrees counterclockwise, it will actually have the same shape as the histogram, because you'll see that these are higher, you know, this is slightly higher than the first 2, the whole 9 yards. So, the stem and leaf plot accomplishes exactly what the frequency distribution and histogram accomplish, but they actually give you specifics. So you can look at this data and analyze it and say, oh, I can find my median. Median's easy. There's 11 things, 1, 2, 3, 4, 5, 6, bing, bing. There's your middle, median's 30. You see? You can get your specific information from here. All right, so I wanted to remind you of all